Here we're going to explain how to properly set up a plotting sheet so that you have it set to whatever location on Earth you want it to be. When you do this, I guess before I start with anything, you want to know whether or not you're trying to get a single fix or if you're trying to do what's called a day's run, where you're going to be getting all of the shots over a course of a single day or just over a long period of time. Because if it's a single fix, it's obviously ideal for you to design everything out so you start right in the center. Makes things easier for you to plot on. But if it's a day's run, you'd want to start off to some side somewhere. That way you have all the width of the paper to plot across. Before we even get to that though, let's say you're going to be given a location at the beginning of any CellNav problem. It's going to be a DR location, so like your last known fix or just your last DR. Let's say your last DR was 23 degrees, 15 minutes north, and 84 degrees, 30 minutes west. Okay. So latitude is easy. You can just set any one of these lines. You know, there's five of them total on a sheet to whatever latitude you want for whatever is going to be easiest. Actually, I'm going to add on here. Say you're on course 230. True? Okay. And we're going to do a day's run in this. Actually, no. You know, for this example, we'll just do it based off of you only care about your shot right now. So the course doesn't even really matter. The next one will have course matter. So for your latitude, you want to pick what latitude you're going to set as the center of the paper, as the one that everything's defined off of. And in this case, seems reasonable if we're only caring about our shots right in this exact moment to use 23 degrees. I don't know how well you can see that, but we'll just say, yeah, trust me, it says 23 degrees up here. So you can just set this first one as 23 degrees north, which case this could be 22 degrees, 21 degrees, 24, and 25. That's not complicated. You can see on the scale here, if I zoom in a bit, you have a scale going up for minutes, showing you, an easy measurement of minutes throughout these degrees of latitude. The next step, though, is to calibrate your longitude. And the way we do that, I'll just so you can see a little bit better, is using the compass rose, like I said. What you're going to do is you're going to mark 23 degrees away from the horizontal at in every quadrant here on the compass. So it's easiest to do it right here, obviously. 23 degrees up above the horizontal, just because that's the central latitude we're using. Here's 10, here's 20, so 23 is right there. You do the same down here, 10, 20, 23. Then you come to this side. Now it's numbered, starting around 270, so you can't just count as easily, but this is 10, this is 20, so that's 23, 10, 20, 23. Now that you've done this and you've marked these 4 points, what that means is that you could, if you connect the dots, making sure that you remain parallel or perpendicular with the horizontal here, what you get, I hope you can see, but I'm lined up perfectly with both of those two marks I made. That is 60 minutes of longitude at the level of 23 degrees north. So this right here, you can see, would be 1 degree of latitude from here to here and 1 degree of longitude from here to here. And then if I connect the dots on this side, Same on that side. So 1 degree of longitude, 1 degree of latitude. So now we actually have a scale we can work off of. The next thing you're going to do is, you can measure out distances on the latitude scale, and you can obviously measure latitude on the latitude scale, but you can't, nothing here is allowing you to measure longitude realistically other than knowing that this is 1 degree. But that doesn't help you. You want to be able to break it down more cleanly. That's what this is for. So the way you use this is you measure out the distance of 1 degree of longitude, which would just be from your central meridian to the meridians you just drew. Make sure that's accurate. And then this is just a good way to double check your work. Make sure you're doing it correctly. Come down here, measure it's the same. Same. Just to make sure that you weren't very, very slightly off in any of your angles. If these all come out to be the same distance, then the scale is accurate. Okay, it is. What that means is this right here is equivalent to 1 degree of longitude. You then take it over to your scale here, and you slide it down until it lines up perfectly and hits the outer edge of the scale on both sides. So you can see, if I just make an impression where they landed, you can see here's 20 and here's 30. So this right here has got to be 25. Our points landed just below the 25 on both sides. So if we do it again, should land at approximately the same point. You could then bring your triangle, gotta move this. Make sure it's even. Make sure it's perpendicular to this line here, just so we know everything is coming out in a straight line. And then you connect those 2 pinpricks you made. That's gonna be a little lower like that. And what you get is the equivalent of 1 degree of longitude, but drawn out on this scale now, meaning that all these like subdivisions of it can be used to measure out distances. You can see each of these are marked 10 minutes away from the 0, 20 minutes, 30 minutes, 40. And then these on this side are the ones place, but it's actually in twos. So 2, 4, 6, 8. Meaning you can measure longitude accurately to 2 minutes. If I wanted 43 minutes of longitude, I could put my 1 point on the 40. Well, if I wanted 42, I could put my second point on the second little line off of the 0. If I wanted 43, I could put it halfway between the 42 and the 44. If I wanted 27, I'd put this one on 20, this one on 6, and then just go out halfway to 7. So now you have a calibrated longitude scale on the chart that you can actually plot things down on, and one you can use to measure longitudes off to the side. So we're going to do this again at a different scale, just to show how it works in multiple ways. I'm going to say, oh, actually, before I do that, last thing you would want to make note of is which one of these meridians are what. So if we said that we only care about our central location here, like I did before, then we would probably want to set this as also our central meridian as close to the one that we measured off of here. So I said we're 84 degrees, 30 minutes west. Well, west increases that way. So 84 degrees, 30 minutes. If we said this is 84, that would give us somewhere around here. If we said this is 84, that would give us somewhere around here. Because we're going on a westerly course, it would actually be better to label this up top as 084 degrees west. This one then is 085 degrees west. and 086. And now we have a completed, or at least a prepared plotting sheet so that we could immediately find our DR position in this area and we would be able to plot fixes on it. Now we're going to do something extreme. We're going to say we're very far north. We're going to go 57 degrees 20 minutes, actually 57 degrees 20 minutes south, and 022 degrees 45 minutes east. So south works just the same as north. At this point, you actually have a choice on your own of what you want to do, because as you can see here, the latitude scale goes 0, 10, 20, 30, 40, 50. That's true for the north. In the south, it's obviously reversed, and this is 0, 10, 20, 30, 40, 50, meaning you could do one of two things. You could just rewrite these as in the other direction, or if not rewrite them, just remember that it's in the other direction, or you could rotate the entire sheet upside down. That way you automatically see what the numbers are. The only issue being everything is upside down and any of the writing is upside down as well. But I think if anything, what that will serve to do is you'll always remember that you're in the south. You won't get confused because it's very easy to forget that and start working in the wrong direction. So I think we're going to do it this way. Step one is we set our central latitude. In this one, I think we're going to do it as a day's run. So before we start, I'm going to put in a course and say we're on course 087 degrees true. And now instead of aiming to put ourselves right in the center like we did in the previous one, we're going to aim to put ourselves off to the side. That way we have the whole chart to work with. So we're 72 degrees south on a course of 087. So we're going basically due east, meaning we want to start somewhere over here. We're also not changing our position north-south that much. We're only going a little bit north. So I think it's that we're going enough north that I think it would be smart to choose this right here to be 57. Wait. Yeah, 57 degrees south. And then this would be 56 degrees because the increase is going this way. We'd have 58 degrees here. 55, 54. So now we have our latitude set. Step two is to plot them out on our compass rose. So we'll start over here with the numbers that are easier. 1, 2, 3, 4, 10, 20, 30, 40, 50. You can see there's the 50. And we come down to the 7. 10, 20, 30, 40, 50. 7. 10, 20, 30, 40, 50. 7. 10, 20, 30, 40, 50. 7. There are all our points. Now you just connect the dot. Never, if ever you feel the triangle slip, don't just tell yourself that it's fine, it's not that big a deal, it's not going to change it that much. It will. You always have to go back and redo it, no matter how frustrating it is. So we get that. Obviously, we're really far north here, so a degree of longitude is really small compared to a degree of latitude. Then we do the same over here. Good. Now what you'll notice though is this is not a large area to work with. These are the only 4 squares that we've created that you could actually plot and consistently understand what degree you're in. And if we're going to be working an entire day's run, what it would be smart to do is to actually copy these lines out more, so you expand your grid as much as you can. So you measure out this distance, which should be equal to this distance, and then you don't even need to mark it just yet. Just prick the paper well enough that you can clearly see it, which I don't think you can clearly see it, but I can clearly see it. Hopefully you can see I made 2 little indentations there. Probably manage one more off to the side here. Then you do the same in this direction. 1, 2, 3. And now you can just extend this out. Line your triangle up perpendicular with the latitude lines, with the parallels. Make sure they pass through the indentation you made. And draw out more meridians. Good. Then come over here and do the same on this side. Usually, like, obviously how far north you are, or how far north-south you are, determines how many of these you need to draw to fill out the page. Usually it's not going to be this many because we're really far north in this situation, but at least it is good practice. Okay. Now we've set up the page to actually be consistent throughout. We do have to label these meridians though. So I said that we are 22 degrees 45 minutes east, and we're on course 087. So we're going this way across the page, meaning you probably want to start on this side of the page. So if we need something to be 22 degrees east, if we need some point to be that to start with, it should probably be this one, because if we picked this meridian, we'd end up off the page. So we're going to make this 22 degrees east, meaning that 2245 is somewhere over here, but it's still like on the page and we're working this way. So this will be 21 degrees east. Then we just work this way, 23, 24, 25, 26, 27, 28, and 29. There. Now we've set up our paper to actually be calibrated to get ourselves situated. We still need to set our scale though. So we measure out 1 degree of longitude. Make sure it's consistent by double checking with some other points. Looks good. We bring it over to the longitude scale. Slide it down, and you can predict where it should land. It should be somewhere between the 50 and the 60, closer to the 60. And that's where we get. Prick those 2 points so you can see them. I hope you can see them. And then set up your triangle. There. Draw a line across, and you can label that 57 degrees south. And now you can measure longitude values off of that. And with that, we have a fully prepared plotting sheet so that we can put down fixes on it.